Hello everyone and welcome back to our Power Thinking Skills revision video. Let's get started straight away. Okay, number 4. A sheet of paper is folded half in 4 times from the longest side each time. If the dimensions were originally 100 by 100, what is the final area after folding? For these folding or reflection or symmetry questions, I really highly recommend you guys draw, okay? So let's first draw up a square. We have 100 by 100. We're going to fold it from the longest side. Well, there's no longer side here because they're the same, so it doesn't really matter which side. We're going to fold it like that. And what do we get? We'll get a rectangle that looks like that, 50 by 100, because we folded it in half. So we need to halve that dimension. Now we're going to fold it again from the longest side. So fold it down this way, and what do we get? We get another small rectangle, 50 by 50. Okay, so we folded it twice already. What do you notice is happening? We're actually dividing each side, okay, one time on the width, one time on the length, by half each time. So we're 100, 100, 50, 100, 50, 50. So next we're going to get 50 by 25. And then the final fold will get 25 by 25. Okay, do you see what we did there? So what would that be? The area finally would be 25 by 25. And if you multiply that, well, you know that would be 6. Sorry, let's write that again. 25 by 25, you'll get 625 square centimeters. And that's option. Okay, sorry for this one, ignore this. I accidentally added another line. Okay, so question 8. Harold is sitting a university entrance exam. The exam consists of 4 sections labeled A to D, varying in difficulty, and they tell us the number of questions in each part. So which one would help Harry complete the exam the quickest? So all you have to do for this one is really work out A to D, the amount of time that's going to take to complete the respective number of questions with the time provided. So let's try for A. For example, 3 minutes for part A, so per question, 3 times 15. I'm going to add that to 5 minutes for part B. You have 8 questions, so 8, let's do that. 5 times 8 plus 8 minutes for part C. So 5 questions in part C. So we're going to do 8 times 5 plus and 15 minutes for part D. So 3 times 15 or 15 times 3. So we get 45 plus 40 plus 40 plus 45, which is 90 plus 80, which will give you 170 minutes for A. And you have to do that for the rest of them and then compare them. Obviously, this is quite tricky given the time constraints, but trust me, there are going to be questions like this, okay, or in a similar way where they kind of try and stall your time. Okay? And the purpose of these questions is to figure out who can complete such questions. They're easy calculations, but very easy to get wrong as well. Who can complete them in the most accurate and timely fashion. So when you get questions like this, don't get stuck. If you mess up a calculation, don't lose confidence. Guess an answer, circle it, and make sure to come back later, okay? Sometimes that panic in the moment does not help, so please remember that. For this specific questions, you can see from the solutions I figured out, and D comes out to be the shortest time or the quickest time with 167 minutes. So that's why D is the answer for this question. You can try figure it out on your own like I did here. Okay, 12. So we have 6 friends standing around in a circle, and they're evenly spaced apart, and there's one person opposite another in each scenario. What we're going to do is draw up a quick diagram where we have 6 friends, okay, and they have one person directly opposite them like that. Now, the fascinating thing about circles is you don't really have to decide where you start, because wherever you go, you can rotate the circle, okay, and there can always be a new person at the top, but it's just the whole thing rotating around. It doesn't really matter where you start. The only thing that matters is how everyone's placed in relation to each other. So first of all, let's read the first statement. B is standing to the left of E and standing on C's right-hand side. So I'm going to put B here. Yeah, B here. And they are standing to the left of E. So where would E be? Here, right? To the left of E. See, B is on the left of E and C's right-hand side. So C is going to be here. See how B is on C's right-hand side. Now, neither A or F are standing opposite to B. See, B is here, so this can't be A or F. Who's left? C, B, and E are gone. A and F are gone, so the only person left is D. This must be D. So now A or F left. This one's done. On D's left-hand side is a vowel. So think about you as person D, you're facing inwards, that's your nose, okay? Where would be your left-hand side? Your left-hand side would be this side, right? That's your left-hand side, this is your right-hand side. This must be a vowel, which is A, and F must be here, the only one left. Now, the important part here is that they want you to find a statement which cannot be concluded. Don't do all of these amazing work and accidentally select the one that can be concluded, which should be 3 out of the 4 options, okay? So A, F is on the left-hand side of C. F, left-hand side of C, correct, so A is out. B, A and C are standing opposing each other. Yes, they are, so B is out. E is on the right-hand side of A. E is here, A is here. So in relation to A, E is on the left-hand side. And this one says right-hand side. So actually C is the answer because it cannot be concluded. Okay, 16. So which of the statements, if true, most strengthens the above conclusion? What is the conclusion? Let's get our highlighter and highlight the conclusion. So we have deciduous trees, okay? They are quite a common sight in most of the northern hemisphere, but quite rare in Australia. Why? And one of the main reasons for this is related to Australia's unpredictable climate, and they go on to explain what is unpredictable about Australia's climate. So that's kind of the main point as to this paragraph, telling us about why deciduous trees don't grow that well or quite rare in Australia. So what would strengthen this conclusion? The answer is A, okay? Because this conclusion concludes, okay, or our highlighted bits, they show that deciduous trees are not common in Australia because of our unpredictable climate. This directly links to why they are common in the Northern Hemisphere. As I said, they are common in the Northern Hemisphere, and we can assume or we can infer that it's because they are predictable weather, unlike Australia. So A directly links to this conclusion very well with 2 main linking points, so that's why it is the best answer. Okay, 18. So Tom claims that more people are taking public transport. In the box it says total money generated. The total money generated by public transport has increased by 5%. And Tom assumes that because most people don't have a driver's license, there are more children taking the public transport. So what has Tom done wrong? So Tom has assumed that this total money generated is purely because more people are taking public transport, whereas that's not the only way the money can be increased, right? The total amount of money. A very possible reason or that increased is by a thing called inflation or price raise, okay? They might have increased the ticket prices, and that's why the total money generated or the total revenue has increased altogether. So this direct relationship between the number of people with the total money generated is not reliable or not inferable. So what is wrong about his assumption? The answer is D, that ticket prices have stayed the same. Okay, they might have, and his assumption might be correct, but we can't directly assume it just now without extra evidence. 23 is a question of probability. you need to be aware of the fact that when you remove a marble because you picked it out of a bag, okay, you are not just removing that single marble, but you're also decreasing the total number of marbles in the bag. So we have 3 yellow and 6 green. He pulls 2 marbles at random, one after the other. So the first marble, what is the chance it's a yellow? We have 3 yellow and the total number is 9, right? 3 plus 6. So that's the first probability. Now, what happens to the second marble? Well, there's only going to be 2 yellow marbles, but then again, out of the total, there's only going to be 8 marbles remaining because we picked one out regardless of if that was yellow or green, okay? So 2 out of 8. So to find the actual probability, you're going to times. And before you do that, you can simplify 1 over 3, and this would be 1 over 4, and you get 1 over 12 as a result. So D is your answer. 24. Which one would weaken Susie's argument? What is her argument? Let's highlight it. Susie says, it is important to spend lots of time on my phone. It helps keep me entertained and talk to my friends. By going on my phone right before bed, it means I don't miss out on a single thing. So we want something to oppose directly Susie going on a phone a lot. And the answer is D. Excessive use of technology. She has admitted herself that she spends lots of time. Okay, so that links. Particularly mobile phones. So we are focusing on the phone. That links again. Has proven to have detrimental impacts on one's eyesight. So it directly kind of addresses this focus of the question, and it provides a very strong reasoning as to why her argument is not very valid. It weakens the argument directly. So D is your answer here. Okay, 26. Which is the best approximation for the sum of all numbers between 1 and 100 inclusive? This has a trick, and now I'm going to show it to you. So I'm going to write up the first 3 numbers. I'm going to do an ellipsis and go to 98 plus 99 plus 100. Those 3 dots mean all the numbers in between. I'm not going to write them all out because it will take me all day. So a trick that you can do when you add a lot of numbers together and they kind of have a pattern or rule going in between them. Add up in pairs. What I mean by pairs, each pair should have the same sum. 1 plus 100 is 101, 2 plus 99 is 101, 3 plus 98 is 101, and if you keep plussing, think about it, okay, 4 plus 97, 5 plus 95, so 96, and it keeps going, it's going to produce 101 each time. And how many pairs do we have? Well, we're linking the each ends together, so we're actually going to have 50 pairs, okay, because it's 1 to 100, that's 100 numbers, 50 pairs. Each pair is going to be worth 101, so all you have to do is 101 times 50, and that would roughly equal 5,000. Okay, if they're about 100 times 50. So option B is the answer. Okay, 36. Which of the following conclusions are best supported? Let's highlight the main ideas of this passage. So, it originally was developed for medicinal uses, gunpowder, but it quickly became apparent that a mixture had potential to be used in many other applications. After its introduction, gunpowder was seen as an essential tool for medieval combat. So essentially, this whole passage is talking about the multi-usages of gunpowder after it was invented. Okay, so best supported would be option B. Many uses, okay, links to the potential to use in many other applications. Again, popularity in different applications directly links to this part as well. So 2 links again, which is a very good amount for this question. B is the correct answer here. Okay, for 38, the pattern actually is a rotation. We have 90 degrees clockwise rotation, and then you reflect, okay, along the vertical axis. So we're going to rotate that shape 90 degrees clockwise, Okay, and it's going to be a rectangle with that block here, and the dot here, and the base like that. If I flip that along this vertical axis, okay, you see how it can turn into this shape? That's what's happening on our shape as well. It's going to rotate, okay, and flip, and you actually get D as your answer when you do that. So let's quickly end with maybe just one takeaway today, okay, one key takeaway. So today I want to talk about the art of drawing, okay, so for symmetry questions, okay, or area or volume questions, or for counting shapes, or for reflection questions, okay, heaps of other questions as well. Draw, I'm going to write this in caps, okay, a simple diagram, okay, label your diagram and try to keep it neat. So when you add new information, it doesn't get lost, okay? This is crucial as sometimes questions tend to get very complicated, okay? Yeah, so please try and draw these diagrams, and that will definitely help you out. I always do it whenever I do the test myself, okay? So please do it. Thank you for bearing with me in such a long video, and till next time, try to keep that takeaway in mind and apply it in your next exam. Thank you very much, and see you soon.